Okay, salam sejahtera and welcome back. Okay, so today we will continue with the next subtopic 3.7. Okay, 3.7, page 72. Okay, is electrical energy and also power. Okay, so first we learn what is electrical energy first. Electrical energy. So electrical energy. Okay, this is 3.7 electrical energy. Okay, so electrical energy E. Okay, so consider a circuit. Okay, consisting of the battery that is connected by a wire to an electrical device. So the battery is connected with the electrical device, okay, such as lamp, a motor, okay, or a battery being charged as shown in figure. Okay, where the potential difference across the electrical device is V. Okay, so assumes that this is a electrical device. Okay, for example, lamp or fan. Okay, so this is an electrical device, and this is the battery. Okay, a current I, if there's a current flowing through from terminal A to terminal B, okay, if it flows for the time T, the charge that flow, which it carrier from B to A is given by, okay, so if let's say there is a current flowing, kalau dia ada arus, if let's say there is a current flowing from A to B, okay, from A to B, meaning that the electron, okay, will come out from terminal, okay, electron will come out from terminal negative, and then electron will flow from terminal negative to terminal terminal B, okay, to terminal A. Okay, so this is the difference between the current. Current will flow from terminal positive. Okay, current will come out from terminal positive of the battery, but electron will come out from terminal negative. Okay, of the battery. Okay, so if let's say there is a current flowing through, meaning that there is a charge flowing from B to A, okay, because electron is attracted to a positive plate. Okay, so our current is equal to dq over dt, okay, meaning that the rate of charge flow is equal to our current, or we can write it as our charge equals to IT, okay. Then the work done on the charge B to A equals to the electrical energy supply. So we can write it as, still remember chapter 1, we learn work done. Now work done is the charge times the change of potential, electric potential. Okay, so we can write our work done equals to delta VQ. Okay, this is chapter 1, what we have learned. Okay, we learn V final minus V initial over Q. Okay, so V here actually is the potential difference across terminal A and B lah. Okay, perbezaan. Okay, so we can write it as our work done equals to E. E is the potential energy. Okay, this is work done. Okay, work done equals to potential energy because VQ also equals to potential energy. Okay, potential energy, change of potential energy, or we can write it as V still remain Q, we substitute Q, okay, we substitute Q become IT. Okay, we substitute our Q become IT, because Q equals to IT just now. Okay, so we substitute. So therefore, if the question say what is the energy supply, electrical energy supply by the battery, so we can use these equations to calculate. Okay, so this equation is IV times T. Okay, if the electrical device is a passive resistor, okay, passive resistor meaning that the device which convert all the electrical energy become heat. Okay, so sometimes if let's say when we on the power supply, okay, and when there's a current flowing through, okay, you will feel that the device, the electrical device become hot because all the electrical energy, okay, all the electrical energy already convert into heat. Okay, heat dissipated. Okay, Maksudnya electrical energy itu dia akan tukar kepada haba. Contohnya kalau lampu dia juga akan panas. Okay, you feel the heat. Okay, or maybe the fan. If you on the fan for a longer time, that's why your fan will become hot. Okay, when you touch the fan when you touch the lamp or the bulb, you will feel the heat because there is a heat dissipated. Okay, so we can also write the heat dissipated in the electrical device, okay, is equals to our work done, okay, our energy dissipated, okay, energy dissipated, okay, ataupun energy loss equals to I V. Tapi V ni adalah V for resistor. Maksudnya resistor di dalam bulb, di dalam kita punya fan maksudnya motor lah. Okay, times T. Okay, or we can also write as I square R times T. Okay, or we can also write as V square, but this V is of course resistor from the potential difference across the electrical device times V square over R, okay, times T. Okay, so this is the energy loss as a heat. Okay, this is the energy dissipated inside the electrical devices. Okay, if let's say is they ask the electrical supply. Okay, if let's say the electrical supply maksudnya the energy supply from the battery. Okay, of course, if let's say our E supply, okay, supply meaning that this supply here we are referring to the supply by the battery. Okay, yang dibekalkan oleh battery. Okay, supply by the battery. If the question says supply by the battery or the source, okay, we also can use I, okay, V become EMF lah because it's battery. T, or we can write, we also can write I square. Of course, this R is R total. Okay, because it's applied to the internal and also external. Okay, or we can write it as EMF square over R of course R total lah. Okay, R total times T. Okay, this is R total, R total. Okay, so this is the energy supplied by the battery. So when the question says supply by the battery, your EMF you must take, the potential difference you must take EMF. Okay, because we want to take the V total. If the question say heat dissipated, okay, heat the energy, okay, heat dissipated, okay, ataupun energy loss as a heat. Okay, so we must use the potential difference across the electrical device. Okay, so this is energy, electrical energy. Okay, meaning that we have two types. The first one is energy supply by the battery. The second one is the energy loss as a heat or energy dissipated as a heat. Okay, ada yang satu yang dibekalkan oleh bateri, satu lagi adalah tukar kepada ataupun hilang sebagai haba. Okay, so kita ada dua jenis electrical energy. Okay, next similar for power. Okay, power is defined as the energy liberated per unit time in the electrical device. Okay, so our power we can write as work done over T, or we can write work done equals to IVT over T, because our power is equals to energy over time. So therefore, our power we can write as, okay, if you cancel TT is equals to IV, or we can write as I square R, okay, or we can write as V square over R. Okay, V square over R. V square over R. Okay, and power is a scalar quantity. Okay, it's a scalar quantity, meaning that we don't need to consider the direction, and the unit for power is watt. Okay, so maybe we can try one questions. Okay, we can try one questions. Example 13. Okay, example 13. So example 13 is the battery has an EMF. So this is V battery. Okay, this is the source. Potential, potential difference across the battery. And there is an internal resistor 1 ohm. Okay, meaning that inside the battery there is an internal resistor. Okay, determine the rate of energy transfer to electrical energy by the battery. So meaning that the first one we want to find is the energy supply by the battery. Okay, we want to find the energy. This is the energy supply by the battery. Okay, supply by the battery. So of course, when we say energy supply, we must take EMF. Okay, we must take EMF. So either your internal resistor is 1 ohm, your EMF is 12 volt. Okay, and there's a external resistor. Okay, external resistor is equals to 5 ohm, equals to 5 ohm. Okay, so it's equals to, okay, so our and rate of energy actually they are referring to the power. Okay, rate of energy, meaning that the power equals to, okay, equals to energy over time. Okay, so this is what they want to find, energy over time. Okay, so our equations we have okay, we have either IV. Okay, we have I square R. Okay, or we can write V square over R. Okay, depends which one is easier. Okay, if you want to use IV, because it's a battery, meaning that we want to take EMF. So if let's say IV, meaning that you must take I, V is EMF. But the problem is I, we don't have I, but we can calculate using this equation. EMF equals to V external plus V internal. Okay, or we can write EMF equals to I R plus I R internal. Okay, so we substitute inside. Our EMF is equals to 12. Okay, I, because it's series, so we take out I. R external is 5. R internal R resistor is 1. So meaning that our current is equals to 12 over 6. So it's equals to 2 ampere. Okay, it's equals to 2 ampere. Okay, so you calculate is equals to 2 ampere. Okay, so just now this one is equals to I R, and this one is 5 plus 1. So you will get 2 ampere. Okay, so if let's say you want to use the first equations, so you must substitute 2. Of course, your EMF is equals to 12. So your answer is equals to 24 watt. Okay, 24 watt. Okay, if let's say you want to use I square R. Okay, if let's say you want to use I square R, you also can use. But make sure R must take total resistor because the power, the power supply is for internal and also external. Okay, so you must take total resistor. Okay, including internal and external. If you want to use I square R also can, meaning that your I is 2 square and your R, okay, R is 1 ohm plus 5 ohm. Okay, 1 plus 5 internal and external. Okay, you add up together. Okay, so press the calculator. Okay, what? So you will get also 24. Okay, you also get 24 watt. Okay, similar if let's say you want to take this equation, you substitute inside, okay, you will also get the same answer lah. Okay, 2 square, 12 square over 6. Okay, so 144 over 6, 144 over 6, you also get 24. Okay, 24 watt. Okay, so this is the power supply by the battery. Okay, this is a power supply by the battery, meaning that we must take everything in total. Okay, next question. Find the rate of heat dissipated, meaning that the power dissipated. We want to find the rate of heat dissipated, okay, in the battery. Okay, why there is a power dissipated? Because there is a internal resistor. Okay, there is an internal resistor. Okay, there is an internal resistor inside the battery. So that's why there is a power loss, power dissipated inside the battery. So when you touch the battery, you will feel the hotness of the battery. Okay, so power dissipated. Okay, so it's either equals to IV, okay, or equals to I square R. Of course, this R is the internal resistor because it's inside the battery. Okay, or you can use V square over R. Okay, of course, your V here, of course, is because it's internal. So V must be internal. Okay, you cannot take EMF. You cannot take EMF. So I think the easiest one is I square R. Okay, so if you take I square R, meaning that your I just now is 2 square, and the internal resistor is just now is 1 ohm. So total is equals to 4. Okay, power dissipated is equals to 4 watt. Okay, is equals to 4 watt. So this is the power dissipated, power lost inside the battery. Okay, inside the battery because there is an internal resistor. Okay, next question is, okay, the amount of heat. Now we only want to find the heat, not the rate of heat. It's heat only. Okay, meaning that the energy loss. Okay, the energy loss in the 5 ohm resistor. Okay, if the current flow through it is 20 minutes. Okay, so now we want to find heat. We don't want to find the power. Okay, so for this case, what should we do is either you take the total power, okay, P total, okay, P total or the P supply. Okay, P supply, okay, equals to P internal plus P, okay, plus P external. Okay, so P supply just now is 24 by the battery. Okay, and P internal, P that lost inside the battery is 4. So meaning that P external, okay, P external is equals to, P external is equals to 20 watt. Okay, is equals to 20 watt. Okay, so our energy, okay, is equals to, okay, P equals to E over T. So our energy is equals to P times T. So our P is 20 watt and the T is 20 minutes, 20 times 60. Okay, so you will get, okay, press a calculator, you will get 2.4. Okay, 2.4 times 10 to the power of 4 joule. Okay, okay, it's 2.4 times 10 to the power of 4 joule. Okay, so this is the method how you find the energy loss. Okay, or the other way, okay, we also can use directly the equations. Okay, we also can use the equation because we know that P loss, the energy loss. Okay, if you refer back to your notes, the energy loss we can write it as, okay, so here energy loss we can write it as I V, of course V is V for across the 5 ohm resistor times T, or you can use I square R T. Okay, but V, because V we don't have, okay, V here we are referring to V for 5 ohm, meaning that this is V external, but we don't have. Okay, so we can use I square R, okay, meaning that your I is 2 square and your R is 5 ohm, and the time taken is 20 minutes, is 20 minutes. Okay, so 20 times 60. Okay, 20 times 60. Okay, so is 20 times 60, you will get 1200 second. Okay, second. Okay, so you will also get 2.4 times 10 to the power of 4 joule. Okay, so that's all for today. So you must remember what is the supply and also loss. Okay, so that's all for today. Thank you, class. We'll continue with the next lesson. Okay, so thank you, class. See you.